You're listening to Worth Electronics What's Up radio podcast, where each week we are checking out what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and our own Worth Electronic technical specialists. We're going to shine a light on interesting topics such as energy harvesting, wireless power transfer, EMI issues, and so much more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with the Worth Electronic What's Up podcast. In today's segment, we are discussing cracks on molded power inductors. We're also showing the visual asymmetry around the core that could occur during the manufacturing process of our WE-LHMI inductor series. The WE-LHMI series inductors have an optimized molding technology, especially designed for low-profile, high-current applications like laptops, tablets, battery-operated devices, and the list goes on. It's used where the need for high-current, high-stability point-of-load devices are increasing. The advantages of the WE-LHMI series products include high saturation current, which exhibits soft saturation characteristics, low core losses, high operating temperature, and a small footprint. Unlike most of the power inductor cores, LHMI core is not a ferrite. Instead, it's a mixture of iron powder and resin binder, which is pressed around the inductor coil. The resin binder creates a distributed gap and greatly enhances the electrical characteristics of an inductor. After pressing, the mixture, along with the inductor coil, is cured in an oven to increase the bonding strength between resin binders and iron powder. Unlike other manufacturers, the WE-LHMI series are coated with varnish to avoid oxidation around the core, which can affect electrical properties of an inductor in the long run. While it might be nice to have a good visual appearance, due to the manufacturing process involved in the molding process, the process and core material have limitations in maintaining that perfect visual appearance, which we will explain the effects that can be seen later on. Even with and without visual imperfections, the LHMI products have passed all industry standard tests like thermal shock, mechanical shock, terminal strengths, vibration, humidity, moisture resistance, operational life, and many more. These imperfections do not affect the reliability or the performance of the WE-LHMI series products. Cracks that occur around the core are nearly impossible to eliminate since the molding process involves curing the resin binder and the iron powder together. During this process, small cracks are caused by wall friction when ejecting the component. Unlike in ferrite powder inductors, minor to moderate and major cracks may occur, but they still do not affect the performance of this series. In order to ensure the best quality, Worth Electronic has set up standards for production to control the intensity of cracks before their release. The length of a hairline crack should be less than 1/3 of the left and right side of the terminal, otherwise they are deemed as rejected parts right at production. An example of a rejected part is shown as H in attached figure 1 of this podcast. Visual inspection takes place during the manufacturing process. This is generally done under a magnifying glass, CCD camera, or even 10 times optical inspection. This gives an accurate measurement of any imperfections. As shown in figures 2 and 3, there is evidence of visual cracking, but as this is within specification, these are perfectly usable since the crack is less than 1/3 of height H, whereas figures 1 and 4 show rejected parts at production line. All other cracks must be less than the height H to be accepted. Now, while those parts might be accepted for hairline fractures, any crack on the surface is deemed unacceptable. Cracks can also occur at bottom side near the pad surface. If the crack is less than 2 millimeters, the components are labeled as acceptable. Since WE-LHMI series contains iron, oxidation may occur in worst-case scenarios. Obviously, they will not be acceptable. Unlike other manufacturers of molded inductors, WE-LHMI components are coated, so oxidation may not occur around the core at all. In any case of oxidation around the core, the component is labeled unacceptable during the production process. Oxidation can also be avoided from the customer's side by storing components away from heat and humidity in sealed packages until it's time to mount them on the PCB. Much like cracks, a chip-off can occur during the manufacturing process of the LHMI products. Even though the amount of chipping does not have any effect until the coil is exposed or broken, Worth Electronic does have standards to facilitate customer concerns and visual appearance. Chipping usually occurs on the edges, surface, and corners of the inductor. The only parts that are acceptable during production is if the chipping on the surface is less than 1 millimeter, if the chipping at 2 surface junctions is less than 1.2 millimeters, and the chipping at surface of 3 junctions is less than 1.5 millimeters. Even with the visual irregularities, several electrical and reliability tests have been done on the WE-LHMI products, and they've proven there is no effect on the performance or the reliability. As major chip-off is the worst condition to happen to the inductor, comparison of electrical performance is made with and without the chipping. A synchronous step-down switching regulator is implemented using an LTC 3810 controller and the LHMI 744-373-68068 inductor. The DC-to-DC converter is designed to handle 60 watts of power, switching at 250 kilohertz. The DC-to-DC converter is designed with an input of 24 volts and an output of 12 volts at 5 amps. The perfect WE-LHMI 6.8 microhenry inductor without any visual difference is used in the testing, and the resulting values are 11.78 volts, 5.02 amps with 93% efficiency. The same test is then repeated with 15% chipping of the original inductor, and they get the same results. And figures 12 and 13 waveforms are shown for the inductors with and without the chipping. In summary, the WE-LHMI core is not a solid core. Instead, it's an iron core molded around the winding. To match the requirements of modern electronic load demands, it's important to look at the inductor technology, which gives stable inductance into high currents while maintaining a compact design. The molding technology gives us many advantages, but in the process can give us some minor imperfections. While many of these imperfections are only on the surface and they do not affect the reliability or performance of the product, it is still required that Worth Electronic continues to minimize these imperfections. Also, Worth Electronic quality control is constantly setting up standards during manufacturing process to ensure better reliability and performance. To find more information and to order your free samples of the WE-LHMI Inductor Series, visit Worth Electronic online at www.we-online.com. You can also download this application note by clicking the link available in this podcast. You're listening to the Worth Electronic What's Up radio podcast, where each week we are seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and Worth Electronic technical specialists who are going to shine a light on interesting topics like energy harvesting, wireless power transfer, EMI, and so much more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with the Worth Electronic What's Up podcast.